Hello viewers, welcome back to my channel. This session is all about the page size. So this topic also comes under design issues for the paging systems, and this is the formula to find the value for the page size. But rather than just remembering the steps to derive the formula, you have to know the complete idea behind why this derivation is required, how to decide the page size, on what basis the page size is decided. In memory management, you have been seeing that the main memory is divided into equal size partitions, and in equal size partitions all the pages are brought in from the secondary memory. The secondary memory is also divided into equal size partitions called as pages. What should be the size of the page? So just remembering the steps for the derivation is not enough. Even in the examination, if a question is asked on write short notes on page size, then you have to completely explain first the background and then start deriving this particular formula. How to decide the page? I'll write it in very simple sentence. How do you decide the size of the page? So in the numericals and all till now, whatever you have learned the different, normally we have come across what a size of the page size is 4 KB, page size is 2 KB, page size is 1 KB. Like this, you have been seeing the values for the page sizes. Now, if at all, if these are the values that are given in the numericals, exactly the system how it decides, because we say that the complete secondary memory is divided into equal size partitions called as pages, and even similarly same whatever is the size of the page here in the secondary memory, the same size is there in the main memory also. So that means on what basis the system is deciding the page size. So for that to understand, I have come out with an idea of first writing the parameters. So let me just take one parameter and then decide what should be the page size. Normally, if at all I have to tell in general, I will use the word a larger page size or smaller page size. Now I am not using any value for the page size, just I'll tell whether you want a larger page size or a smaller page size. For that, let us take one parameter here and then decide whether we'll go for the larger page size or the smaller page size. So the very first parameter I have chosen is number of pages. So let us take for example, if the virtual memory size is 4 MB. Virtual memory, the size of the memory is how much? 4 MB. If it is 4 MB and if the page size is, okay, if the page size is 1024 bytes, then for this memory, if each page size is 1024 bytes, then 4096 pages are needed, right? Number of pages are how many? 4096 pages. Now for this, to make you understand, for this I am just telling it is a larger, okay, larger page size. Suppose if I want to do this for a smaller page size, then I will just try to reduce this size of the page and I'll make it 512 bytes. So for me, this is smaller, okay, whatever number I am taking here, because I have taken 1024 as larger, now I will take 5012 bytes as, 512 as a smaller value. Then if 512 bytes are, the size of the page is 512, then I require here 8092 pages, okay. So first we'll see how many pages. If the size of the page is larger, you require this many pages. If the size of the page is smaller, you require this many pages. Quite obvious, because depending on the size only, you are going to decide the number of pages. So this is what I have written here. The first parameter is, let us see the number of pages. Now why I am interested in number of pages is, number of pages will decide the size of the page table. That is what I have written here, the next point, size of the page table. Because you know what does page table stores? Page table stores the information about each page. There is a row for every page, okay, in which frame it is residing. So if there are 4096 pages, then there will be 4096 entries in the page table. If there are 8192 pages, then there will be 8192 entries. That means what is that I wanted to tell is, if the page size is large, the size of the page table becomes small. Size of the page table is small here. Whereas if the page size is small, then the size of the page table is large. Normally what we prefer is, no, we want a smaller page table. This is what normally we prefer, okay. If at all smaller page table, then you have to have a larger page size. This is how these two are related. Now let us see the impact of internal fragmentation on this. What is the impact if the page size is smaller, and if the page size is larger? Now here I have taken larger. No, suppose when the pages of a processors are brought into the main memory, if each page size is 1024 bytes, okay, now normally what will happen? No, the last page of a process will never get filled up. So just we will take, okay, it is 50% filled. So if every page is 1024 and if the last page of that particular process is not occupying the complete space, let us take this is the unused space here, and if I assume it to be 50% unused, then 512 bytes is wasted in this case if the page size is larger. If the page size is smaller, okay, if each page size is 512, and if the last page is not taking the complete space, then what will happen? Out of that, okay, last page size 50% is not is unused, then we can say 256 bytes are wasted. So here wastage of internal fragmentation is more in this case, more where if the page size is larger. If the page size is smaller, internal fragmentation is less. So what is that we prefer? We always prefer lesser internal fragmentation. Next is what? Page faults. What is the impact of page faults here? See, if the number of pages are more, okay, the contents of the pages are also less. If the contents of the pages are less, if the CPU is demanding every time an instruction wherein that page is not present in the memory because you are having what? You are having smaller size pages, then page faults will occur frequently here. Whereas if you have a larger page size, then the chances of having page faults more is very, very less in this case. So lesser page faults will be there in case of what? In case if the page size is larger. So another parameter what I have mentioned here is transfer time. It is actually input output time or the time to read a page. The time taken to read a page consists of or composed of three different times in turn, and those are the seek time, latency, transfer time. So to read a particular page also from the hard disk, these three times are needed. These three times are there, and one is the seek time. Suppose if I'm taking normally some value here 20 millisecond, for latency let me take 10 millisecond, and here let me take 0.6 millisecond, then 30.6 millisecond is the time to read a page. If the page is larger in size, 30.6 millisecond is spent here to read that. That is how much the larger. Here I am taking 1024 bytes. Now if you are taking a smaller page size 512, then this 30.6 millisecond was used in order to read this page, one page. But here the size, since the page size is smaller, once again what? 30.6 for this page and 30.6 for this page. So totally it becomes what? 61.2. You are spending double the time. And one more point I have written, wastage of memory. This wastage of memory is different from internal fragmentation. See, if a page size is larger, okay, CPU is interested in reading an instruction which is present only in the beginning of the page, okay, but the page size is how much? 1024 bytes. Maybe the CPU is interested in reading an instruction which is there in the first 128 bytes itself only, that instruction is covered. Let us assume that CPU is interested in reading an instruction which is covered in the first 128 bytes, but the page size is 1024. That means you are going to bring the entire page here. No other go. You cannot bring 128 bytes only. So because the complete page has to be brought in the memory, then definitely what? There is more wastage of memory here. But if the page size is smaller, if you take for example the 512 only, even though the instruction covers 128 bytes, so not much space compared to what the larger page size, the wastage is there. This is what when you try to see the different factors and try to find out whether we want a larger page size or a smaller page size, but every time what is that you are seeing for larger page size, some factors are giving good results. For smaller page size, few factors are giving good results. So what is the conclusion? The conclusion is you have to make a compromise between the two, and to make that compromise only, this is the derivation. To arrive the formula for the optimum page size, you need what? Here the S denotes process size, you need the page size, you need the size of each page table entry. and then you can, once you get these three values, you can find out the number of pages. Pages needed is what? S divided by P. So this is what I have explained here also. See, if this is the size of the process, S here I have written, no, process size is 4 MB. If page size is 1024 bytes, then you are getting 4096 pages. 4 MB divided by 1024, you will get 4096 pages. So these pages occupy, now whatever are the number of pages you got, these pages occupy SE divided by P bytes of page table space. Then what is the wasted memory due to fragmentation? The P divided by 2. P is what? Page size. So we are assuming what? 50% of the page is what? Wasted due to internal fragmentation. So this is what is P by 2. Now the total overhead will be this term plus this term. So this is what I have written here. Now in these two terms, the first term will be larger if the page size is smaller. The second term will be larger if the page size is what? Larger only, because here it is due to, the second term is related to internal fragmentation. Then optimum value must lie in between these two. To get the optimum value, you have to take the first derivative with respect to P and equate it to 0. Once you take that, you will get these values. So first derivative, hope you people are knowing, the derivative of 1 by x is what? Minus 1 by x square. So here SC divided by P and plus P by 2, when you take the first derivative, you will get minus SC divided by P square plus 1 by 2 equal to 0. Finally, you equate it to P. P is what? The page size here, which is given by under root of 2 into S into E. So this is the formula that can be used to calculate the page size. So if there is a simple numerical given here wherein the size of the page, size of the process is given, and E is what? 8 bytes, that is size of the each table entry we require. Value for S and D, if it is given, then you can easily calculate the page size. Here letter P indicates page size and S indicates what? The size of the process. Substitute the values, you will get what? P equal to under root of 16, which is equal to 4 KB. So in this case, the page size is 4 KB. All commercially available computers have got page sizes between 512 bytes to 64 kilobytes, remember. If a question is asked on page size, first you try to give the importance of page size and then come with the derivation for the page size. Hope this session is useful to you all. If you find it useful, please like, share and subscribe to my channel. Thank you. Bye bye. Take care.